the second part of problem 21. 21b it is. Now, instead of a Volkswagen Beetle, we have a dragster kicking it from 0 to 60 miles an hour. And now we know the time, and we want to know the acceleration. Okay? So I've done a little bit of both things, D and U of doofus. So we drew the picture here. Acceleration is our we want to know thing. What we want to know. Time 0.600 seconds. Other stuff, same as last time. We just have 26.8 meters per second. No need to do all that again. We did it. If you didn't see that part, go back and check out video A or video 21, problem 21, part A. All right, so now what we're going to do is we just set all this up, and we're just going to run through. Just like before, well, do we have the same equation? What is it that we're missing? Again, delta x is missing. So it will be exactly the same equation as last time because, as I said, our typical deal is that we will determine which formula we use by what's missing. That's the easiest way to go about it. So, as with last time, our formula is VOTET. V equals V naught plus AT. Now we're looking for the acceleration based on the time and the change in velocity. So rearranging, we get A is equal to V minus V naught over T. This should look familiar because this is really the definition of average acceleration, isn't it? You can see that this is delta V, V minus V naught. And the reason that our acceleration here, our acceleration for this problem is the same as average acceleration is because acceleration as a condition of this type of problem is going to be constant. So acceleration is the same now as it was at the beginning. It's the same as the average was. All right, so now all we have to do is we have rearranged. We've done our algebra, and now we're going to plug in values, simplify and solve. So 26.8. So acceleration is going to be 26.8 meters per second minus 0 divided by our time, 0.600 seconds. All right, and meters per second divided by seconds is going to be equal to meters per second squared, which is what we want for an acceleration. All right, so dimensionally, our construction seems sound, so we'll go with that. All right, so 2.68 divided by 0.60000 gives us acceleration is equal to 44.7 meters per second squared. All right, that is crazy acceleration. That's not 44, is it? Wow, yep, 44 meters per second squared. And that's like what we would call, it's about 4.5 Gs. You may have heard that when people are accelerating quickly, like astronauts or jet fighter pilots, they talk about their acceleration in Gs. Basically, this is if you have G force of 4.5, if you're pulling 4.5 Gs, then you feel 4.5 times heavier to yourself. That's like, eye popping kind of and blacking out kind of G's if you don't have special suits to keep all the blood from leaving your head. So that's pretty monstrous acceleration there, 44.7 meters per second squared for the dragster, going from 0 to 60 miles an hour in less than a second. Pretty amazing.